Hello everyone, welcome to our next lesson. Today we're going to be looking at mathematical induction. Now when we do a mathematical induction kind of question, usually it follows the same format. First of all, you check for one number when n equals 1 or n equals 0. Then you assume for when n equals k, and then you check when n equals k plus 1. And it becomes kind of like a domino effect. What you're going to do essentially is, it works for the ninth term. It works for the ninth term if it works for the eighth term, and it works for the eighth term if it works for the seventh term. It works for the seventh term, sixth term, and we know that the first term works, so it becomes a domino effect, and therefore it works for all numbers. So let's just look at the question and go for it. So this question, we've got the left-hand side is equal to the right-hand side, and we're going to be proving that. So first of all, let's just check for when n is equal to 1. So check for n equals 1. Okay, so on the left-hand side, we've got 1 times 1 factorial, which is equal to 1. And on the right-hand side, you've got 1 plus 1 factorial minus 1, which is 2 factorial. 2 minus 1 is equal to 1. So it checks for n equals 1. So it's true for n equals 1. Next, we're going to assume that it's true for k. So assume it is true for n equals k. And then we're going to check when it's n equals k plus 1. But let's just write down what this means. So n equals k, so that means going from n to r equals 1. So it's not n anymore, it's now k. From r to r factorial is equal to k plus 1 factorial minus 1. Okay, so now we're going to check for k plus 1. So check for k plus 1. So when n is equal to k plus 1. Alrighty, so let's see what happens. So from k plus 1, from r equals 1 to k plus 1 of r times r factorial. Well, if we look at that, that is the same thing as going from r equals 1 to k plus k plus 1 to k plus 1. And we already know what this is. That is just what's up here. So just scroll down a little bit. This is equal to k plus 1 factorial minus 1. Then we just have to look at this one point. When it's k plus 1, what do we got? Well, we've got plus k plus 1 times k plus 1 factorial. So let's play around with this. So we've got a k plus 1 and k plus 1 factorial here. So we could factor that out, k plus 1 factorial. And what you get left is, well, this is 1 and this is plus k plus 1. And you also got this minus 1, so let's just put minus 1 here. And this is equal to, well, k plus 1 factorial times k plus 2, so that's actually equal to k plus 1 factorial minus 1. And that's what we were trying to get. If you look at the original question, that's what we're trying to get, that it's equal to this plus 1 factorial minus 1. And this one, we had k plus 1. Yeah, we got k plus 1 factorial minus 1. So it worked. So we're just going to have to write our concluding sentence. And therefore, n equals k plus 1 is true when n is equal to k, or when n is equal to k is true. And since n equals 1 is true, which we proved at the beginning, then the result is proved by mathematical induction for all n belonging to positives from 1 to infinity. Generally, this is how mathematical induction is done. It's always the same steps. Just sometimes you have to use little different tricks for mathematical induction. Hope that helps. Have a good day.